Hello everyone. Today let's solve the Leetcode problem number 208. So implement trie prefix tree. So what the question says here, first they have given the definition of trie. So let's try to understand. A trie, pronounced as trie or prefix tree, is a tree data structure used to efficiently store and retrieve the keys in the dataset of the strings. So this is the tree data structure used to efficiently store and retrieve the keys in the data set of strings. So there are various applications of this data structure such as autocomplete and the spell checker. So we are making use of the autocomplete in the search engines and on, right? And spell checker as well. So this is, they have just mentioned some of the applications, right? Such as autocomplete and the spell checker. So we have to implement the trie class where trie initializes the trie object. Void this one, void insert string of word, inserts the string word into the trie. Boolean search string word, this returns if the string word is in the tree. Next, this one finally returns true if there is previously inserted string word that has the prefix. And we have to return false otherwise, right? So in the input they have given trie, this one, apple search app starts with insert app. So output, this has to be null null, true false, true null true. So explanation they have given this one. So let's write the code first. Let's understand the code and then I'll just explain the same by taking example this example, right? So first what I'll do, I'll just come here, just give me a second. First we are this one, the trie, this one, right? The first one. What we will do here, we will initialize the trie data structure with an empty object. So I'll just make use of this dot trie equals, this is first thing, and the second one, trie dot this method. So insert method they have given second, right? So what we will do here, first initially we'll start from the root of the trie. So I'll just give let current equals this dot trie. So here, okay, this is fine. Next, let's split the word into characters and iterate through the each character. So we will be splitting the word into single characters, individual characters, and we will be iterating through the each character. Let's make use of the for each for this, right? First, initially, let's split the word. Then dot for each, so individual character. So if the character is not already present in the current node, so character is not present in the current node, then we are adding it, right? Simple. So if not of current of within the, we are making use of array, right? Within the character, that is if character is not already present in the current node, we have to add that one, right? So char, this one, this is fine. Next, what we will do, we will move to the next node in the trie. So trie consists of the tree-like structure itself, right? So next we will move to the next node in the trie. So how can we do that? I'll just initialize current to current of. So this is it. Next, we will mark the end of the word in the tree finally. So I'll just give current dot end equals, let's set this one to true. So this is it for the insert method. Next, let's go to the search method, right? Initially what we'll do, again, we'll start from the root of the trie. So same thing here, what we have done. I'll just copy this one. Let me copy this line and paste it over here. So next, let's iterate through the each character of the word. So I'll just make use of for loop. Let char of word dot split. So this is fine. Then what we will do, if the character is not found, if the character is not found, then the word is not at all present in the trie. So we are searching based on the characters itself, right? If the character itself is not present in the trie, then the word is not present in the trie. So in my case, I'll just give In our case, I'll just give if not occurrent character, then we will return false. Else we will move to the next node in the trie, right? So for that, this is same thing. This one I'll just copy this line. After this, and of care. So what we are doing here, we are moving to the next node in the trie. Next, let's return true if the end of the word is marked same. So let's return true. Again, I'm telling if the end of the word is marked. So where we will, while inserting, we had seen that. So this one, we have marked the end of the word in the trie while in the insert, right? So here in the search, if we are returning true only if the end of the word is marked. Otherwise, we will return false. While I explain the example, you will come to know. So I'll just come here. So let me return dot end. This one true, else we will return false. This is one thing. The final one will go with starts with. We'll go with the starts with method, right? So we have the this one parameter prefix. So next this one, the first one is as usual. We are starting from the root of the trie. Let me copy the first line and let me paste it over here. Next, what we'll do, we'll iterate through the each character of the prefix. Let me copy this one as well. So I'll just make the necessary change. Here, instead of word, we have prefix, right? So let me change this one to prefix. So yeah, this is fine. Then again, if the character is not found, no word with the prefix exists. So then we'll be returning false. I'll just copy the exact same thing. If current character, we will return false. Let me paste it over here. Same thing, exact thing. Then we'll move the next node in the trie. So exactly same thing here we are doing. I'll just copy this line. After this line, let me paste it over here. Next, we will return true if all the characters of the prefix are found. So if all the characters of the prefix are found, then we'll just return true, right? This is simple. Return true. So let me format the code once. So yeah, this is it. Let me submit. Let's check. So if line number 21, right? So here, this has to be current. Yes, has to be CURR, not CWR. This is fine. So in number 33, again, same mistake, right? Typo. So yeah, now this works correctly, right? So this works correctly. Let's understand this one with the example. So let's consider this example, right? So the example one. So initially the operation of trie, this one we are considering. So the input that we have given is this one. And the action, we are creating a new instance of trie. If we can see here, we are creating the new instance of trie. Output will be null, basically. Why the output is null? We are returning, the operation, or we are not returning any value, right? The trie method here, we are not returning any value. So the output will be initially null. So the second one is insert of apple, this one. Insert apple, this one, right? So initially what we'll do, we will start at the root of the trie. So nothing but start at the root of the trie is nothing but we will just insert A initially. This one, sorry, let me take this one, A. Same goes with next P, P, L, E, right? P. This one will be P, P, L, and finally E. So this will be E, right? So we will mark the end of the word as E. We are marking the end of the word as E here. The last letter is E, right? So we'll mark the end as letter E. This is nothing but APPLE. So yeah. Next, what we are doing here, input apple action that we are inserting the word apple into the trie. We have inserted the apple word into the trie. Output will be again null. Why the output will be again null? Here in the code you can observe that the operation does not return any value. So we are not returning any value here. So the output will be again null. The second one, this one, right? So let's come to the third one. Nothing but search of apple. This one, search and apple. So what we are doing here, let's start at the root of the trie. Just give me a second. Let me delete this one. So let's continue with this itself. So let's search for the apple. We are starting from the root of the tree. We will check for the same APPLE, right? For the search also. So now it will be for the search operation A, P, P, L and E finally. So this one will be E. So the end of the search is marked at E. So here also we have E. We have inserted E, right? And the end of the search at the end of the search is also E. So the search is successful. We have E here and the end of the search is also E. So here this is the search is successful. So we will get the output true basically. Why we are getting the output true? The word apple is found in the trie. So here we have also marked the E as end of the word as last E, right? So the search will be successful and the output will be true. That's what we have got here. So let's move to the next step. So I'll just delete this one. Just give me a second. With here after the search function, we have starts with, right? So let me come here. Just give me a second. We will come to the fourth one. Nothing but search of app. This one. So search of app, what we'll do, we'll start from the root of the trie. So we'll search for A initially. So A, P, P, A, P and P, right? So let me write in the trie. So this will be A, P and P. Although, so app exists, so just give me a second. Although app already exists as a prefix, right? In the apple that we have inserted. So although app exists as a prefix, the end of the word is not marked as P. We have marked, if you remember, we have marked the E as end of the word, right? In the apple. So the end of the word is not marked as P. So the search will be unsuccessful here for this one. Search of app will be strictly the end of the word should be the inserted one. Nothing but in this case, last we saw E. So here the end of the word in the app is P. So app is present as a prefix, but the last letter is E. So the search will be unsuccessful. So we are returning false in this in that case. So this one false, right? So next it is starts with. So this is also fine. Starts with app, right? Starts with app. So what we'll do? We'll start the root of the. We'll start at the root of the trie. Nothing but from the A, P, P. So check for the A, P and P. This one again, same thing. So the prefix app exists in the trie. So the operation will be successful. So the app is present in the trie already, right? So the operation will be successful and we will return true in this case. So that's what we are doing here. True, right? Next, insert of app. So this one, insert of app we are doing. So insert of app, we'll start with we'll start at the root of the trie. We'll insert A, then we'll insert A, then we will insert P, then again we will insert P. So this one again, this is nothing but APP. So we will mark the end of the word at P now. before we have marked the end as E. Now we will mark the end as P. So now the input, now the input of app will be, the action will be, we are inserting the word app into the try. The output will be null again. So why we are getting the output null? In the insert function, we have already seen here in the insert function, it doesn't return anything. We are not returning any value in the insert function. So this will be null. So I'll just delete this one. So this one, so that you can see the last but one, this is null. The final one is the last step. So search of this one, search of app. So the step is, we'll again start at the root of the try. We will check for A, P and P. So the last one was A, P and P. If you remember the last one, A, P and P, right? So we will check for A, P and P. Then the end of the word, in the last, this one, insert, we had already inserted A, P, P, and we had marked the end of the word as P, right? So the end of the word is marked at the second P. So the search will be successful this time. This time the search will be successful, and the output we will get is true. And why we are getting the output true? The word app is now found in the try, as we had inserted, right? Inserted app in the last step. So now we have the output null, true, false, true, null and true. Same thing as the output. So this works completely fine. So what will be the time complexity and the space complexity? So let me come here. The time complexity of the insert function would be big of n. So why the time complexity is big of n? Because each character of the word is processed only once. So the time complexity I would give big of n. The space complexity would be big of n as well. Why? We add a new node for each character of the word, as you have seen. So this will be big of n as well. So this is one thing. This is for the insert function. Next, what's this time and space complexity for the search function? So here also the time complexity would be big of n. Why? Because each character of the word is processed only once. So this will be big of n. The space complexity would be big of 1. Why big of 1? We are not making use of any additional space. Proportional to the input size is being used. So the space complexity would be big of 1. The final one, this one, starts with function. So what's the time complexity? The time complexity would be big of n as well here. So for this also the time complexity would be big of n. Why? Because each character of the prefix is processed only once. Same thing, right? So the space complexity would be big of 1. Why? We are not making use of any additional space. That's proportional to the input size is being used. So I'll just give space complexity as big of 1. Nothing but constant. So this is it. Yeah, what I'll do, let me just comment this one. This is just for my reference. Let me comment this one as well. Sorry. Yeah, let me hit the submit again. Yeah, this works absolutely nice, right? So yeah, this is it. Thanks for watching, guys.